Hello there. What we are going to do now is to look at solving a logarithmic equation, an equation that has logarithms of the variables that needs to be solved by using properties of logarithms. So with this equation, the one thing that we want to look at first is to notice that I have our log of our variable in two different terms, but then I also have a constant term. So this isn't one where I would be able to just use the one-to-one property of logarithms because I'm not able to get the log expressions on each side without anything else over there. What we'll do to this though is we'll make sure that we get all the expressions that involve the logarithm of the variable on one side of the equal sign. So the first step we're going to do here is to add the log of x minus 21 to both sides. So we have log x plus log of x minus 21 is equal to 2. Now our goal here is to use properties of logarithms to write it as the log of an expression on one side and the number on the other side so that we can write it out of log form and into exponential form to solve. Now recall that if we have log A plus log B, that's equal to the log of A times B. And we looked at that in terms of expanding it out, where we have the log of a product is the sum of the logs, and also condensing, which we'll want to do here. So because we see that this is a addition in between, this condensed back is the log of x times x minus 21. So you want to think of that left-hand side kind of exclusively as when you were practicing condensing logarithmic expressions to get it written as a log of one argument on the left. And this is equal to 2. Now that we've got that, we also see that it's spelled log, but there's no base showing. And remember, when it's that log spacing with no base, that's a common log, so that means this is base 10. And sometimes it's just helpful to write it in there. Now we're going to write it out of log form into exponential form. Our base is 10. The exponent on the base, well, logarithms are exponents, so what the logarithm is equal to, that's your exponent. And then the quantity that it's equal to is the argument, the x times x minus 21. So rewriting this, we have 10 to the second power is equal to x times x minus 21. Now 10 to the second power is 100. And x times x minus 21 is x squared minus 21x. So now we notice that this is quadratic. We can solve our quadratic equation by factoring, if it's factorable, completing the square or quadratic formula. If we want to solve by factoring, remember we need to have a 0 on one side of the equation. So we're going to subtract 100 from both sides and look to see if that is factorable. The leading coefficient's 1, so we want the factors of negative 100 that add to get negative 21. Well, those numbers are negative 25 and positive 4. So I have x minus 25 times x plus 4. Setting each factor equal to 0, I get x minus 25 equals 0 or x plus 4 equals 0. So x equals 25 is a possibility, x equal negative 4 is a possibility. But when I have an equation that starts with logarithms of variables, you always have to check your solutions to see if they satisfy the equation, because the logarithms have a domain of the argument has to be greater than 0. So we need to make sure that's true, and it also needs to make the left side equal the right. So let's first check x equal 25. So log of 25, is that equal to 2 minus the log of 25 minus 21? Well, when we look at this and simplify in the parentheses, I have the log of 25, and I want to know if that's equal to 2 minus the log of 4, because 25 minus 21 in parentheses is 4. And when you put these through your calculator, you'll see that you'll get the same on the left as you do on the right. And I'm taking the log of positive quantities, so yes, that checks. X equal 25 is a solution to our equation. How about x equal negative 4? Well, it would start off with log of x negative 4, log of negative 4. I don't need to keep going after this. The log of negative 4 is not defined over the reals. So x equal negative 4 does not work. The actual solution to this equation is x equals 25.